Hello students, we will be having the session on addition of vectors, especially the discussion of parallelogram law of vector addition at 2:30. Join the session at 2:30 guys. Okay, waiting to meet you all. Take care till then, take care. Attend the other session. I will share you the link just before 5 minutes of the session. Method. Now, to add vectors, you can use different methods, different laws. You can add vectors by using different laws. Some of them are parallelogram law of vector addition, triangle law of vector addition. You can also say polygon law of vector addition. Okay. Now, in this session, we will discuss only parallelogram law of vector addition. Parallelogram law. When this can be used, and by using this, how to find the sum of two vectors, resultant of two vectors. That is, try to understand with some examples. Okay. First, write down some heading: parallelogram law of vector addition. Yes. Parallelogram law. Parallelogram law of vector addition. Parallelogram law. So before going ahead, I would like to give first the statement of this parallelogram law, what it states and how we can make use of that statement to find the sum of two vectors, like we can say the resultant vector, and then how to find its magnitude and the direction of the resultant vector. We will see these points one by one. First, the parallelogram law of vector addition says, if, listen first, then you can go down, if have two vectors. If two vectors represent two adjacent sides of a parallelogram, provided these two vectors should have the same initial point. Those kind of vectors are called concurrent vectors. Co-initial vectors are concurrent vectors. So if two concurrent vectors, let us say this is vector P and there is another vector Q. Right? If these two, you can understand the statement in the one or the other way also. So let me give you the both ways of what you call the statement. If two vectors gives two adjacent sides of the parallelogram, or if you have a parallelogram, usually parallelogram will have opposite sides. I can say opposite sides will be the parallel sides. If two adjacent sides of a parallelogram are represented by two adjacent sides of a parallelogram are represented by two concurrent vectors, both in magnitude and direction, then the diagonal, it will have, this is one diagonal, this is another diagonal of a parallelogram. The diagonal passing through the common origin. The diagonal passing through the common origin will give you the resultant of these two vectors, both in magnitude and direction. This statement is called parallelogram law of vector addition. Okay? So write down the statement clearly, then we will proceed. Write down. If two adjacent sides of a parallelogram, if the two adjacent sides of a parallelogram are represented by represented by two concurrent vectors. Two concurrent vectors are represented by two concurrent vectors, comma, both in magnitude and direction. Both in magnitude and direction. Both in magnitude and direction. Then the diagonal of the parallelogram, passing through common origin, and the diagonal of the parallelogram passing through common origin. This is also a diagonal, but we don't want this diagonal. The diagonal which is passing through common origin of the given two vectors. Okay? The diagonal of the parallelogram passing through common origin gives the resultant vector both in magnitude and direction. Both in magnitude and direction. Both in magnitude and direction. Right. Look here. Once again. Yes? Here? Once again look here. So that as I told you the statement, the words in the statement, we can shuffle the words. Instead of telling two adjacent sides are represented by two concurrent vectors, then the diagonal passing through the common origin gives the resultant vector. You can also say, if two vectors, instead of in the starting, you can start with this. If two concurrent vectors represent two sides of a parallelogram, two adjacent sides of a parallelogram, then the diagonal passing through the common origin gives the resultant vector both in magnitude and direction. You can change the words, but meaning should be proper. Okay? Right. Now, let us see here. P vector is our first vector, Q vector is our second vector. Let us say the angle between these two vectors is theta. Draw this. Let us say the angle between the two vectors is theta. Mention the diagram. Now, if you want to find this, as this is nothing but the diagonal of these two, you have to consider this is O. For following, this is actually this is vector P vector. Okay, and this point you can take it as A. So OA represents P vector. Following, and this is Q vector. Let us take this point O, this point is B, so OB represents Q vector. OB represents Q vector. Then the resultant is given by this point of this is diagonal is represented as C. So OC is represented by the resultant vector R. Okay? Now, for what we are trying to understand by using this is, we are trying to understand how to find the magnitude of the resultant vector by using parallelogram law, and the direction of resultant vector with respect to the horizontal or with respect to this first vector or second vector by using parallelogram law. First, let us try to understand. First step, let us try to understand to find magnitude. To find magnitude of resultant. Let's say R vector. Magnitude of R vector, that is resultant vector. Resultant here is nothing but sum. Means you can write this resultant is nothing but P vector plus Q vector. How to find the magnitude of this? You know, the length of this diagonal gives magnitude. The diagonal is representing by resultant vector, or resultant vector represents the diagonal. So the length of this side gives you magnitude of this vector. To find this article diagonal, that gives you magnitude of the given vector. How to find? Let's try to understand. For finding this, extend this line and let us draw a foot of the perpendicular from point C onto this line. Is this clear? Switch on the lights. Is this visible? Or I am getting some glaring. No problem. So let us draw a foot of the perpendicular from point C onto this point and mark this point as D. Okay? Now, we have to remember few properties of parallelogram. In parallelogram, the parallel sides will be having equal lengths. These parallel sides will be having equal lengths. So this is Q vector, means its magnitude is given by simply Q. Magnitude is nothing but length of that side. So these two parallel sides will have same length. If its length is Q, this length also Q. This is Q vector. This also represents Q vector. Do you understand? So this length is Q vector. This also will be Q only. Got it? Next point. Another point is this is this Q vector is making angle theta with P vector, means that is with the horizontal. This is Q vector because these two will be parallel. That means this also will make an angle theta with this line. Okay? Now, if you resolve this into rectangular components, if the length of this line will be Q, then you can take this as Q cos theta. Length of this part AD will be Q cos theta. Meaning, it is Q and it is making angle theta with this. According to resolution of vectors, it will be Q cos theta. So this opposite side will be Q sin theta. Resolution of vectors. Do you remember? If any vector is making angle theta with a particular side, that component would be magnitude times cos theta. The opposite one will be magnitude times sin theta. Right. This is Q. This will be Q cos theta. This will be Q sin theta. This is next step. First step, I have to consider the vectors, angle, resultant. Now next step, consider this because these two are parallel. This is Q, this is also Q. Resolve and find these components. Next step is very important, guys. From the figure, if you consider triangle OCD, do you understand? OCD is a right angle triangle because this is a perpendicular line. This angle is 90, so you can consider OCD is a right angle triangle. Can we? Yes. And similarly, ACD is also a right angle triangle. Got it? So from figure, try to write down quickly. From figure, and that is from triangle. From figure, from triangle OCD, by applying Pythagoras theorem, we can say hypotenuse square is equal to side square plus side square. So for this OCD triangle, hypotenuse is OC, that is nothing but magnitude of our given vector, resultant vector, and adjacent, this is one side, OD is one side, CD is another side. Do you understand? So you can say from triangle OCD, by applying Pythagoras theorem, we can say directly OC square is equal to OD square plus CD square. Can we write like this? Right. Don't mix up, try to take properly. Then next you can take this as equation 1. I will give you the derivation first clearly, then we will do numerical class. Derivation you have to understand. This derivation is very important. Right? In board point of view and also in a NEET point of view or JEE, any computer examination point of view. This is very important. Let us say Right? Yes, look. So from the figure and from triangle OCD, bigger triangle, you can say hypotenuse square is equal to side square plus side square. Hypotenuse is OC square is equal to side OD square plus opposite side is CD square. But here OD is nothing but, you can write where, write down quickly, OC is equal to magnitude of resultant vector R, right? And OD is OA plus AD. OA plus AD. Where OA is magnitude of vector P, so you can write this is equal to P plus AD is Q cos theta. AD is Q cos theta. And CD is Q sin theta. Q sin theta. So substitute all these in equation 1, then you can write this as OC square is R square. This implies R square is equal to OD is, this entire thing is OD. P plus Q cos theta is OD. Whole square means P plus Q cos theta whole square plus CD square. Q sin theta whole square. Is this step clear? Next, this is in the form of A plus B whole square. Expand this and square this. Q sin theta whole square is Q square sin square theta. Expand, we get is equal to A square plus 2AB plus B square. So you can write 2PQ cos theta plus Q square cos square theta plus this is Q sin theta whole square, that becomes Q square sin square theta. Here if you observe, Q square is common. If you take this out, you can write as Q square into cos square theta plus sin square theta is nothing but 1. So directly I am taking this as Q square. Can I take? You can write it in bracket because of sin square theta plus cos square theta is equal to 1. You can write it as Q square. So you can write this as P square plus 2PQ cos theta plus Q square or P square plus, bring this Q square here, plus 2PQ cos theta is R square. From this we want magnitude of this vector, resultant vector, that is R. This is R square. So therefore R is equal to what? From this we can write R square is equal to this. Therefore R is equal to square root of P square plus Q square plus 2PQ cos theta. This is the magnitude of resultant vector. Right? Next, how to find the direction of this resultant vector? When you say direction, direction is nothing but angle. With respect to what will be the question? You can say that with respect to Q or with respect to P. First, let us consider with respect to P. Let us consider that our angle made by this with respect to P is alpha. Then, from triangle, right angle triangle OCD, tan alpha is equal to opposite side by adjacent side. Right? Next, write down subheading to find direction of resultant vector. To find direction of resultant vector. Oh, it is not visible in the board. Then copy it down. For our reference, the part is not visible. possible. So let me erase this and I'll write here only. Put it down first. Copy it. So the subheading you can write to find direction of S. Resultant vector to find the direction of resultant. Keep the diagram, and this diagram is important. You have to understand the things from the diagram. So from the diagram we can say tan alpha is equal to opposite side by adjacent side. Here you can write otherwise faster. From triangle OCD. From triangle OCD. Say tan alpha is equal to opposite side, that is CD, by adjacent side is OD. But adjacent side OD can be represented as OA plus AD. So therefore you can write tan alpha is equal to CD is, what is CD? Q sin theta. Q sin theta by OD is OA plus AD. OA is magnitude of P vector, that is P, plus Q cos theta. So from this we can say the direction alpha is equal to tan inverse of Q sin theta by P plus Q cos theta gives the direction of resultant vector with respect to P. Here you have to write that. This gives the direction of resultant vector with respect to P, comma, here I can write with respect to P, with respect to P. Right? Yes. Let us summarize these 2 points. This is briefly about parallelogram law of operation. By using that, you can find the magnitude of resultant of sum of 2 vectors is given by this. Magnitude of resultant vector or magnitude of sum of 2 vectors P and Q, which are making an angle theta with respect to one another. And angle made by the resultant with respect to P is this. With respect to P means you can say first vector. Here P is first, Q is second. Instead of PQ, if we take A vector and B vector, with respect to A, this will be, if it is A and this is B, that will be B cos theta. So you have to take it as B sin theta by A plus B cos theta. With respect to A is the another vector sin theta. So sin theta component of another vector, that is B sin theta by A plus B cos theta. Do you understand? Whereas with respect to this vector, if you want, you can take this as beta. Then you have to extend this. Then you have to draw a perpendicular line. So then OC, then you can mark this as E. This will be a right angle triangle. Then you will get this is P means this will be P. It will be P cos theta. Similarly, this will be angle between P and Q. So P cos theta, P sin theta will get. Accordingly, you will get with respect to Q means this will be Q cos theta by P cos theta by P plus Q plus P cos theta. With respect to which vector? Based on this terms will change. With respect to P is this. Write another one also. And you can write this beta. Beta is the angle made by the resultant with respect to Q. also beta is equal to, you have to understand this what you call simplification process. Then remember directly I am giving you here tan inverse of, I hope you have understood this. This is angle between this is what? So that's the same line. Then this is P, this is P. Are you getting? So we can say that this is Q direction, this is B direction, this is theta, this is P means this will be P cos theta, this will be P sin theta. So in place of 2 sin theta I get P sin theta. So here it will be P sin theta divided by, in place of P plus Q cos theta here, Q plus P cos theta unit. Q plus P cos theta unit. This gives the direction of resultant with respect to Q. Here write down with respect to Q. This is with respect to P. This is with respect to Q. Then that is the magnitude. This gives the direction of resultant vector. That's it. Here let us see few special cases. Based on the special cases also sometimes you get the direct questions. Now write down subheading special cases. Right? Now wait. Write down next special cases. What are those special cases? Special cases. First one, if theta is equal to 0, what does it mean? Here, let us try to summarize once again these expressions. If you have two vectors P vector and Q vector, if they represent and where they are both are having same origin, that is their co-initial vectors are concurrent vectors, and if they represent what you call two sides of parallelogram, then resultant of these two vectors is given by, what is that? Diagonal of parallelogram passing through the common origin. Right? Mathematically, it is given by R is equal to square root of P square plus Q square plus 2PQ cos theta. Where P is first vector, Q is second vector. Magnitude of first vector, P is magnitude of first vector, Q is magnitude of second vector, and in 2PQ cos theta, theta is angle between those two vectors. This is angle theta between two vectors. Got it? Then, if the two vectors are making some angle theta, then the magnitude of resultant of those two vectors is given by us. Whereas the resultant vector is R equal to P vector plus Q vector. Here, if this theta angle between the two vectors is 0, what does it mean? Instead of separated by some angle, if you move this arm to this, so P vector, Q vector both are parallel, the angle between them should be 0. Right? Then what should be magnitude of resultant of the two vectors? Here substitute 0. What is cos 0? Cos 0? 1. So you can write it as P square plus Q square plus 2PQ cos theta. 2PQ cos theta becomes 2PQ. This is in the form of A square plus B square plus 2AB. What is this? A plus B whole square. So you can write this as when theta is 0, that means the two vectors will be parallel. That is, P vector will be parallel to Q vector. Then cos 0 will be equal to 1. Then magnitude of resultant vector, what is that? R is equal to square root of P plus Q whole square. This can be expressed as, or you can write P square plus 2PQ. P square plus Q square plus 2pq is equal to p plus q whole square under root. So root and square gets cancelled. So you get r is equal to p plus q. What does it mean? If the two vectors are parallel, then magnitude of resultant vector is equal to direct sum of the magnitude of individual vectors. Magnitude of first plus magnitude of second. That's it. What does it mean? This is another one, P and Q. Second vector you have to shift so that this will be the second vector. So that the initial points will coincide with the one point of the first vector. Then if you draw a line from initial point of the first to final point of second, that gives the resultant vector. That length will be nothing but the length of this plus length of that. Got it? Next point. Next is some special case. Then what is the direction of resultant with respect to P? Direction of resultant. Resultant also will be in the same direction. So angle B 0. Okay? Next, second case. If theta is equal to 90, that is P vector is perpendicular to Q vector. Right? Then cos 90 is how much? Cos 90 0. Then R is equal to square root of P square plus Q square plus 2PQ cos theta. Cos theta is 0 means this will be 0. So it is equal to square root of P square plus Q square. When two vectors are perpendicular to one another, resultant is square root of P square plus Q square. Did you understand this? If you go back to the resolution of vectors, if you have a vector in xy plane, this is a vector r vector having x component, y component is rx, ry, then r vector can be expressed as rx I cap plus ry j cap. Means angle between them is 0. This component and this component is 90. At perpendicular. Then magnitude of this square root of rx square plus rx square. In place of rx we have p here, ry q. They are perpendicular. Same thing here. Is it clear? In this case magnitude is what? Square root of rx square plus ry square. We have discussed already. This is similar case. So there is a special case of one of the special case of this. Next, third case. If theta is equal to 180. This is for understanding purpose. This I am erasing this. Next, third case. If theta is equal to 180, what does it mean? 180 means P vector is in this direction, Q vector is exactly in opposite direction. So P vector is anti-parallel to Q vector. Then what is cos 180? Cos 180 is minus 1. You have to remember how cos 180 is minus 1, guys. Cos 180 can be written as cos 90 plus 90. 90 plus 90 falls in second quadrant. Cos is negative in second quadrant. So 90 plus 90 is sin 90 minus sin 90. Sin 90 is 1, so minus 1. So this is basic trigonometry you have to remember. Is it clear? Right. Now substitute in that expression. So R is equal to square root of P square plus Q square plus 2PQ cos theta is minus 1. So it becomes 2PQ into minus 1 becomes square root of P square plus Q square minus 2PQ. So it is in the form of A square plus B square minus 2AB. It is A minus B whole square. So if you write it as A minus B whole square, then you can write R is equal to square root of P minus Q whole square, and root and square cancel, you get P minus Q. Therefore, R is equal to P minus Q. So magnitude of resultant is equal to magnitude of the first vector minus magnitude of second vector, or magnitude of the larger minus smaller. Or you can say with the direction, if it is negative, resultant will be in negative direction. Positive, resultant will be in positive direction. That's it. Is it clear? If both are parallel, direct sum gives magnitude of resultant. They are anti-parallel, difference between the magnitudes gives magnitude of resultant. Right? They are perpendicular, magnitude of resultant is square root of a square plus 50 square. Next, these are the special cases we come across in general, the 3 cases. Right? Okay, everyone? Clear? Now, let us do some numericals, simple numericals. So write down. For day scholars, online students already have shared a file. You can go through level 1, exercise 1. Based on parallelogram law. Copy everyone. Glaring, no problem. So did you get addition and resolution based questions sheet all last students? Yesterday? Anyone has not received it? Anyone has not received the questions based on addition, subtraction and resolution of vectors? If anyone has not received, you can collect. Okay? Right. Look. Now let us see some questions. Right, look. Note down the question. Write the question. Question is, the resultant of two forces, the resultant of two forces 2P, the resultant of two forces 2P each. Means first force is 2P, second force is also 2P. 2P each. Wait. Not 2P each. Resultant of two forces 2P and different values are given. 2P and root 2P. And root 2P is root 10P. The angle between the forces is the forces is. So you have to use parallelogram law to find this. How? What is magnitude of resultant of two vectors formula? Yes, we know that R is equal to square root of V square plus Q square plus 2PQ cos theta. Okay, so here magnitude of the first two vectors are given. P is equal to 2P, Q is equal to root 2P, and resultant of these two forces is root 10P. That means R is equal to root 10P. Is it clear? What is given? What we are asked to find? These are the things given. what we are asked to find? Then the angle between the forces. What is theta? Is the question. What is theta is the question. So how to find? By using this, substitute this here. R is root 10p. So you can write up. Otherwise you can write square on both sides. You can also write this as r square is equal to the square on both sides. Root will go off. So p square plus q square plus 2pq cos theta. Yes. Here r is root 10p. Whole square is 10p square is equal to p is 2p. So 2p whole square means you can only do step by step, right? You can do directly. So 2p whole square is 4p square plus q is root 2p whole square is 2p square plus 2 into p into q. P is 2p into q is root 2p, so 2 root 2. So 2 into 2, 4. 4 root 2 p square into p square cos theta. Right? Now you can say 4p square plus 2p square, 6p square. Send this side, 10p square plus 6p square, 4p square. You can write it as 4p square is equal to 4 root 2p square cos theta. Is this step clear? Is this step clear, everyone? Now 4 cancel, p square cancel. The 1 is equal to root 2 cos theta. So cos theta is equal to 1 by root 2. Theta is equal to cos inverse of 1 by root 2. Means for what angle of cos will get 1 by root 2? So what angle of cos will get 1 by root 2? 45 degrees. So this is the angle between the forces. This is how we have to use parallelogram law. You do it fast. We'll be recording. You speak clearly. Right? Right. Okay. One more question. One more question. Yes. Look here. The question is, yes. No doubt. Next, another question. Question is, figure shows, little lengthy question. Write down. Figure shows three vectors. Figure shows three vectors. Is question number 5, level 1, exercise 2, guys. Level 1, exercise 2. Those who are having the questions, you can go to this. Question number 5. Figure shows three vectors. A vector, Now B vector and C vector, where R is the midpoint of PQ, where capital R is the midpoint of PQ. Then which of the following relations is correct? Then which of the following relations, write down simultaneously, relations is correct? And which of the following relations is correct? We have to draw the diagram also here. So this is the diagram. This both have P, Q, and this is R. This is the line. Okay. This is O, P, Q. This is R. R is the midpoint. Here the midpoint of P. R is midpoint of PQ. This is PQ. R is midpoint of PQ. It is mentioned as Z is one vector, A vector, and Z is vector B vector, and Z is another vector C vector. This is C vector. C vector. The directions are given like this. You can write it like this. Okay? This is A vector. Z is, you can draw. This is B vector. This is C vector. Then which of the following relations is correct? To understand this, you need to go through all the basics which we have discussed. So I will give you briefly 2 points. What you can understand here is this A vector, this C vector, and if you observe, this looks like this is one vector, another vector. This you have to consider as one more vector. This is sum of 2 vectors. So you can consider this is from here to here, PR is one vector. Then the sum of these 2 vectors gives the third vector according to graphical method of addition of vectors. If you remember, if this is first vector, second vector, we draw a line from initial point of the first to final point of the second, that gives resultant. From this you can write C vector plus what is that? RP vector is equal to A vector. You can take this as equation over. It is having a little lengthy explanation. You have to follow carefully. And you can also say this B vector and is resultant of C vector plus RQ vector. You can also write that C vector plus RQ vector is equal to B vector. Okay? From the diagram, you can make like this. If you take the sum of these two, what do you get? So this is 1, this is 2. A vector plus B vector is equal to these two. But one more thing, what you can understand here is RP vector and RQ vector, because it is midpoint of this line, are having same magnitude but directly in opposite directions. You can also say RP vector is equal to minus RQ vector. So 1 plus 2 gives what? 1 plus 2 gives what? 1 plus 2 gives A vector plus B vector is equal to C vector. Because of this, these two will cancel out. So you get this relation. That's it. This is based on analytical method of vector addition. Already we have discussed this. Okay, as time up, winding, go, refresh, and come again in the study hour. We will continue. Maybe some 30 minutes. We will discuss few more questions.